Good evening, friends. This is Manjunath Sir, CSAT faculty in IASBABA. In this video, we will be solving the remaining problems of CSAT 2023. This is, I think, second video. Let's straight away go to the first problem. That is, we are doing B series, and this is problem number 79. If today is Sunday, then which day is it? Exactly 10 to the power 10th day. And these are your options: Wednesday, Thursday, Friday and Saturday. 10 to the power 10. If I say 10 square, then it is 100. 10 tens are 100. If I say 10 cube, then it will be 1000. What is the meaning? Meaning, the power indicates the number of zeros in front of 1. Here it is 2, in front of 1 we have got 2 zeros. Here it is 3, in front of 1 we have got 3 zeros. Right? So, in front of 1, how many zeros you will get to see? That is indicated by the power. And here it is 10 to the power 10, meaning in front of 1 we will have how many zeros? 10 zeros. So in front of 1 we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this should be divided by 7. This should be divided by 7. The total number of days to be jumped should be divided by 7. And here you will have to jump in all these many days. These many means how many? In front of 1, 10 zeros. Right? So let me divide this big number by 7. And depending on the remainder, you will have to decide the final answer. If the remainder is 0, then you will have to write the same day, which is Sunday. If it is plus 1, then it will be Monday. Plus 2, that is after 2 days, that will be Tuesday, like this. Okay. So 7 ones are 7. 3 is the remainder. Now I will take this 0. 7 4s are 28. 2 is the remainder. Now I will take this 0. 7 2s are 14. 6. We are concerned with only the remainder and not with the answer. Therefore, be least bothered about these things. Okay. Don't get confused with these zeros, because there are too many zeros. Which zero you are downloading? Okay. Don't forget that. So 6 is remaining. Now I am taking this 0. It became 60. 7 8s are 56. 8s are, we don't want that. 7 8s are 56. 4 is the remainder. Now I will be taking this 0. 7 5s are 35. 5 is the remainder. Now I will take this 0. 7 7s are 49. 1 is the remainder. 7 1s are 7. 3 is the remainder. Now I will take this 0. 7 4s are 28. 2 is the remainder. 20. 7 2s are 14. 6 is the remainder. 6 is the remainder. Now I will take the last 0. 7 8s are 56. 4 is the remainder. So in the end, you got the remainder 4, meaning after 4 days plus 4. This is Sunday. This is Sunday. Today is Sunday. Now you will have to jump 4 days. After 4 days. After 1 day, Monday. After 2 days, Tuesday. After 3 days, Wednesday. After 4 days, it will be the second option. So B is the correct answer, Thursday. The total number of days to be jumped should be divided by 7. Depending on the remainder, you will have to decide the final answer. Okay, we are least bothered about this answer, right? And what else is important here? 10 to the power. If it is 10 to the power, then that power will decide the number of zeros in front of 1, right? So this is everything about this problem. Moving on to the next one. A principal P becomes Q in 1 year when compounded half yearly with R% annual rate. If the same principal becomes Q in 1 year when compounded annually with S, annual rate of interest, then which one of the following is correct? They are same? They are definitely not same, because here it is half yearly and it is annually, but we are getting the same result in both the cases. Therefore, straight away first one is out. Okay. Here half yearly R, annually means 2R. Half yearly rate of interest is R, annually it will be 2R, and here it is annually S, meaning both are equal to each other because they are giving you the same result. The rate of interest R half yearly, 2R annually, S is already annually, and they are giving us the same result, meaning the same thing. P is becoming Q, right, in the same period, that is in 1 year of time. So both need to be equal to each other. S is twice that of R. What is S? S is double of R, meaning S is obviously more. S is more. S is more, R is less, R is less than. Yes, this is the correct answer. R is less than S. S is double of R, meaning S is more, R is less. R is less than S. The third option should be marked. Okay, though it looks a bit tougher problem, but hardly we have done anything here. Moving on to the next one. 40 children are standing in a circle, and one of them, say child 1 has a ring. The ring is passed clockwise. Child 1 passes on to child 2. Child 2 passes on to child 4. Child 4 passes on to child 7, and so on. After how many such changes, including child 1, will the ring be in the hands of child 1 again? And your options are 14, 15, 16, 17. So in all we have got 40 children, and since they are standing like this in a circle, okay, circle shape, then the ring is bound to come back. Okay, if they are standing like this in a straight line, then the ring will never come back, but since it is a circle, it is bound to come back. So total 40 children are there. Child 1 has a ring. The ring passed clockwise 1 2 3 4. Okay, we are not coming back, we are going front 1 2 3 4 like this. Okay, that is the meaning of clockwise here. So don't get confused with this word, especially in this problem. Child 1 passes on to child 2. Child 2 passes on to child 4. Child 4 passes to child 7, and so on. Now what is happening here? 1 has become 2, 2 has become 4. Here 1 is the difference, here 2 is the difference, here 3 is the difference. So you keep on adding natural numbers. First you add 1, then you add 2, then you add 3, then you add 4. This is how it goes, and so on, means that. Okay, so 1, 2, here it is increased by 1, here it is increased by 2, here it is increased by 3. Now let us increase this by 4, then by 5, 11 plus 5, then here it is 5, next it is 6, then 7, then 8, 9. 9 means 45. Okay, 9. Now 10, 11, 12, 13, 14, 15, 1, here it is 2, here it is 3, 4, 5, 6. We have committed mistake here. Here it is 11 plus 5 is 16, 16 plus 6 is 22. Or it only goes to say that it will be just one more. It will be just one more means it will become 121. I hope this is clear. We have missed only 1 by 1 here. It only means this will become 121. What do you mean by 121? 121 means the very first one, because there are only 43 rounds. 3 rounds, 40, 40, 40, 120. 121 meaning it is again back to the very first child. And let's see the number of changes including child 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? So 16. So third option 16 is correct answer. Okay, I hope the method is clear. And don't be least bothered about circle and all. You keep on just adding the numbers correctly, unlike I did. Okay, here I committed mistake, no? So don't commit mistake like that. And every 40, 80, 120, that is the end of the cycles. Okay, otherwise we will, let us solve one more time. First it is 1, then it will become 2 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. If you add 8, you will get 37. Then plus 8 is over, plus 9. Plus 9 means it is 6. Plus 9 is 6, because after 3 it will be end of that cycle. So plus 9 means, right, here it is 7, here it is 8, correct, 9 is also correct. Now it is 10, 10 means 16, 11, 12, 12 means 39, 12 is 39, yes. 13 means 12, 13 means 12, because after 1 it is 12 next cycle, right? So this is 13, next is 14, and then it is 15. What do you mean by 15? 15 meaning 41, right? 26, 31, 41, yes. 41 means back to the first child. So after how many such changes will the ring be in the hands of child 1 again? So here is the child, the first child holding the ring again. Okay, after how many changes, meaning he will have to count only these many things, not 41. He will have to count only these. Okay, it is in his hand, so starting you must include it. Okay, after how many such changes, after these many changes it is back to, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 is the final answer. Okay, so this is everything about this problem. Moving on to the next one. Problem number 59. There are large number of silver coins weighing 2 gram, 5 gram, 10 gram, 25 gram and 50 gram each. Consider the following statements. Consider the following statements. To buy 78 gram of coins, one must buy at least 7 coins. Statement number 2, to weigh 78 gram using these coins, one can use less than 7 coins. Which of the statements given above is or are correct? 1 only, 2 only, both 1 and 2, neither 1 nor 2. See here, 78 gram we want. Okay. Using this, can you do that? No, because 50, 50, it is like 50, 100, 150, 200, this is how it goes. And how about this? It is in the multiples of 25, it is in the multiples of 10, it is in the multiples of 5. But here we want 78, meaning we are forced to use these things, 2 gram coins. How many? Exactly 4. Why? Because 2 4s are 8. 2 gram coins, let me use 4 so that I can go for 8 grams. Remaining 70 you can manage with the rest. Okay. So now you want 70 more. 50 you take 1, then 10 you take 2. That will be total 78. 10 gram 2 coins, that is 20. And 50 gram only 1 coin. Here 50 gram. So all these 3 together you will get 78 grams. And how many coins are a must? 4, 2, 1. And let me tell you, this is minimum. Okay. This is minimum, at least 7 coins. Of course, at least 7 coins we want. Why it is minimum? Because there are many combinations that you will get to see for 78 grams. The reason being, you can use only 2 gram coins. Okay. 39 coins you can go with, right? Or you can go with 5 gram coins, a few, and then use 2 gram. But the minimum, he is asking you, minimum is this thing. So to buy 78 gram of coins, one must buy at least these 7 coins, and this is how it is, 7 coins. Therefore, 1 is correct, undoubtedly. Now let's check out the second statement. To weigh 78 grams using these coins, one can use less than 7 coins. That is wrong. You cannot use less than 7 coins, because if you use less than 7 coins, then you will never get to see 78 gram. Okay, so this is wrong. Minimum 7 is required. So the final answer is 1 only. 1 only is the final answer. Moving on to the next one, a rectangular floor measures 4 meter in length and 2.2 meter in breadth. Tiles, they are of size 140 centimeter by 60 centimeter, and they have to be laid such that the tiles do not overlap. Okay, a tile can be placed in any orientation. You can place it horizontal like this or vertical like this, in any orientation, so long as its edges are parallel to the edges of the floor. What is the maximum number of tiles that can be accommodated on the floor? Maximum number of tiles that can be accommodated. He is not saying you are supposed to use the full area. Okay, maximum how many you can accommodate. Okay, so this is 4 meter. 4 meter means 400 centimeter. 400 meter, 4 meter means 400 centimeter. And coming to the tiles, it is 140 centimeter. From here to here 140. From here to here 140. And then 140, 140, 280 is over. 280 is already over. Still we have got 120 centimeter. So check out the breadth of the tile. It is 60 centimeter. So you can go with 60, 62 combinations here. This is 60 centimeter, one tile. This is 60. Here this is also 60. Right? But here it should be 140. This is 140 height. 140 height. Meaning we have already accommodated 1, 2, 3, 4 tiles. I have used only the length of the floor. Now let's check out the breadth also. Breadth is 2.2 meter. 2 meter means 200 centimeter, then 20 centimeter. Meaning 220 centimeters we have got. This side it is 220. Already 140 height is over. Now how much is left out here? 140 is over, 80 is remaining here. You are left with only 80 height. Here the height is already 60. Still there is a lot of things you can do here. But 1, 2, 3, 4 and same 60, you can go for 2 more here. 2 more. Same 60 belt. So 3, 4, 5, 6. 3, 4, 5, 6. Now you are left out with 400 length and 80 breadth. 480. You can go for 2 more here. Okay. 60, 140. Right. Again 60, 140. Right. So in the end you will be left with only 120 centimeter. Nothing can be done there. Okay. Here also in between you cannot do anything because 60, 60, 60 already 180. Hardly you are left with 40 centimeter here. Nothing can be done there. So 1, 2, 3, 4, 5, 6, 7, 8. So maximum you can accommodate 8 tiles. And it is there in the third option. That should be marked. Right. Moving on to the next one. A flag has to be designed with 4 horizontal stripes using some or all of the colors red, green and yellow. What is the number of different ways in which this can be done so that no 2 adjacent stripes have the same color? So we have 4 like this, 4 stripes. Like this we have got 4 stripes and we will have to paint. Go for coloring. Red we have got, green, yellow. These are the only 3. And the question mark is on. There's one more condition. No 2 adjacent stripes have the same color. Like this we will have to. Keeping this thing in the mind, you must design. See here, if I put red here and red here, assuming I have put red in these 2, okay, then what happens? Now you are left with green and yellow. Once you go for green here, yellow here, next time green here, yellow there. So you will get 2 different combinations here. Okay. If you make these fixed here, once green there, yellow here, once yellow there, green here, 2 you will get, right? Next time what you can do is put red here and here, again the same thing, green, yellow, yellow, green, again 2. These two, 4 are over. These two, 4 are over. Now, you can go for coloring red in these two stripes. If you put red here, okay. Once you go for green here, yellow here. Once you go yellow here, green here. Those two. So total you have got 6. Total you have got 6. Total you have got 6. That is one thing. Now, forget, wherever you are placing, we were concentrating on red. Now you concentrate on green. Green, green. Remaining 2 adjust here. Green, green. Green, green. Okay. Whatever we have done with red, do the same thing with green. There you will get 6. Whatever we have done with red, you do the same thing with yellow. There you will get 6. 6, 6, 6. The final answer is the second option, 18. Okay. So in all, in 18 different ways you can do this exercise. Moving on to the next one. AB and CD are 2-digit numbers. Multiplying AB with CD results in a 3-digit number DEF. Adding DEF to another 3-digit number GHI results in 975. Further, A, B, C, D, E, F, G, H, I are distinct digits. He has not said non-zero digits. He is saying distinct digits, meaning 0 is also included. It can be anything from 0 to 9. So the digits that are allowed is 0 to 9. That is one thing. We have got all these A, B, C, D till I. A, B, C, D, E, F, G, H, I. Till I we have got our distinct digit, and E is already given. E is, wherever we come across E, just write 0, and wherever you come across F, just write 8. E and F, they are already given, and the question mark is on this part, ABC. A plus B plus C is how much? 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the digits which are allowed. And 0 and 8, they are already over. 0 and 8, they are already over. You are not allowed to use them again, only because they are all distinct digits, as he is saying. AB and CD are 2-digit numbers. Multiplying AB with CD, AB into CD, how much you are getting? Results in a 3-digit number DEF. D we know, D we don't know, but E and F we know it is 0 and 8. D 0, 8. What else is given? DEF is over. Adding DEF to another 3-digit number. This is DEF, which is D08. This is being added to another 3-digit number GHI. And the result is, he is saying 975. Till here it is clear. Okay, whatever he has given, I have just written. Okay. Now the calculation part starts. Here is addition. 8 has become 5. Only goes to say that I must be 7, because 8 plus 7 is 15. So I is confirmed now, it is 7. 8 plus 7 is 15. Carry. 0 plus 1 is 1. And this must be 6, only then you can expect 7. So 1 plus 0 is 0. 1 plus 0 is 1. 1 plus 6 is 7. So H will take 6. 7 is also over. 6 is also over, right? Next, D and G together, 9. D and G together 9. You are left out with only the left out digits are 1, 2, 3, 4, 5, 9. These are the left out digits. And these together we want 9. D and G together we want 9. See here friends, if you want the sum of these two to be 9, it can be 0 and 9. 0 and 9 also will give you. But 0 we have already given to E. We are not allowed again to use that 0. So 0, 9 combination is ruled out. So in this remaining, the combination can be only possible combination will be 4 and 5. Do you agree with me? The only combination which will give you 9 is 4 and 5. So 4 and 5 is gone for D and G. One is 4, the other is 5. If this is 4, this will be 5. So 4 and 5 are also over. Now for ABC, we have these things left out for ABC. Out of these 4, one will go with A, one will go with B, one will go with C. And in the end, he is asking you what is A plus B plus C. And see here, if one of the values is 9, then the sum will be surely more than 10. But here all the options are less than 10. Therefore, straight away 9 is ruled out. Meaning 1, 2, 3. Okay. 1, 2, 3. Out of these 3, one will go with A, one will go with B, one will go with C. So it is ABC means 1, 2, 3. 1, 2, 3. A can be 3, B can be 1. Okay, that is allowed. So, but A, B, C will take the values 1, 2 and 3 undoubtedly. So 1 plus 2 plus 3 gives you the very first option 6, and that is the final answer. Moving on to the next one, what is the remainder if 2 to the power 192 is divided by 6? This is a bit tricky question, bit different problem. Okay. Questions have appeared like this before also, but this is not like that. This is bit different. See, we are concerned with the remainder when you divide the number by 6. 2 to the power say 4, how much you will get? 16. 2 to the power 8, 2 to the power 8 is 256. 2 to the power 12 is 4096. And this is a trend 4, 8, 12, 16, right? And in this category only you will get to see 2 to the power 192, which is given here. This is the trend wherein this number, given number will fall, right? This is a series. This is the pattern. Now, we want remainder after dividing it by 6. So, divide this 16 by 6. How much you will get? 6 2s are 12, 4 is the remainder. 4 is the remainder, right? Now, check out this one. 256 divided by 6. 6 4s are 24. 6 2s are 12. Yes, again you are getting 4. Meaning multiples of 4. 4 1s are 4, 4 2s are 8, 4 3s are 12. Everywhere you are getting the remainder 4 when you divide that number by 6. There's one more, check out this as well. Then you can confidently mark the last option 4. Okay. Check out this, whether you will check whether you will get again the remainder 4 or not. Divide this number by 6. 6 are 36, 4, 49, 6 8s are 48, 6 2s are, every time we are getting the remainder 4. So multiples of 4 in the power. Okay. And this is a multiple of 4. 192 is a multiple of 4. 4 4s are 16. 4 8s are 32. Yes. 4 48s are, it is 192. See here, 4 1s are 4. 4 2s are 8. 4 3s are 12. 4 4s are 16. Like this it goes. And it will go till 430, 448s are, it is 192. And in all these cases, when you divide it by 6, you are getting the remainder 4, and that is the final thing. Moving on to the next one. Consider the sequence. This has become a common feature in CSAT. Okay. So this kind of problems are the only thing which is remaining there. Okay. Otherwise, you check the, full CSAT paper as a whole, it has changed a lot, except this kind of problems. Okay. This has become a common feature. Now, what is the trick to solve such problems? ABC dash dash ABC dash DA BBCD dash ABCD, right? The very first thing is you will have to count. You will have to count these things, including the blanks. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. They are in all 20. What do you mean by 20? 4 5s are 20. 4 5s are 20. So it will be a group of 4 items. Then you will get 5 groups. Otherwise, 4 groups of 5 items each. So 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. And after filling up all the blanks using these options, they must show one or the other pattern. Once you get the particular pattern, it can be any pattern, and if you get to see any particular pattern, then that option should be marked. Okay, go with that option. Now let me check the last option, DDCA. Now I will be filling up DDCA. Here is C, here is A. If you check in the very first set, A is there, B is there, C is there, D is there, ABCD is there. Here also ABCD, here also ABCD, there also ABCD. No alphabet is missing. That is one thing. Everywhere we have got ABCD. But ABCD are only 4. But we have made a group of 5, meaning 1 is being repeated. Here D is repeated. Here C is repeated. Here B is repeated. Here A is repeated. This is called the pattern. ABCD, 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 everywhere ABCD. But it's a group of 5 items everywhere. So 1 has to be repeated. Here he is repeating D. Here he is repeating C, here he is repeating B, here he is repeating A, and that is the pattern. Okay, once D is repeated, once C is repeated, once B is repeated, once A is repeated. It is in the order. Okay, if you come from that end, it is A, B, C, D. First A is repeated, first then B is repeated, then C is repeated, then D is repeated. It can be any pattern, reverse or straight, but you must get to see a particular pattern, only then you can mark that option. You check other options and they will not match. That is the reason why last option DDCA is the final answer. Moving on to the next one. In how many ways can a batsman score exactly 25 runs by scoring single runs, 4s and 6s only, irrespective of the sequence of scoring shots? Your options are 18, 19, 20, 21. So we want to score 25 runs. In how many ways you can do it? And you are allowed to go with singles, boundaries and 6s, 4s and 6s, right? Only. You are not allowed to go for 2 runs or triple run, okay, 3 runs or say wides and all, right? So you will have to score exactly 25 runs. In how many ways you can do it? In how many ways a player can do that? That's the meaning of this problem. Now let's see how to solve this problem. 25 runs, and he is talking about 6s also. Assuming in the first case a player has not hit any 6s. That is one case. Case number 2, a player has hit only 1 6. Case number 3, a player has hit how many 6s? 2 6s. He can hit 2 6s because we have got 25. We want 25 runs. And in fourth, he can hit 3 6s. And there is one more. 5th case, he will hit 4 6s. That's it. This is the max. Assuming he has hit 4 6s. 4 6 are 24. Now, to get one more run, go for 1 single, meaning 4 6s and 1 single run. This is the only way out here. In only one way you can do it. If a batsman hits 4 6s, that is the end of it. This is the only possible way. 4 6 and 1 single. This is the only way of scoring 25 runs. Okay. Same way you will have to check 0 6s, 1 6, 2 6, 3 6s. Okay. Now let us go to the 4th case. He has already hit 3 6s, meaning 18 runs are already there with him. 18 runs are already there. Now he will have to go for 25 runs, meaning 7 more runs he wants. 7 more runs can be made in 2 different ways. How? He can hit 1 boundary. He can hit 0 boundaries. These are the 2 ways. Okay. So 5th case, it is only 1 way. 4th case, it is 2 ways. Why 2 ways? Because 3 6s, 1 boundary and the remaining singles. 3 6s, 0 boundary and the remaining is singles. They are the only 2 ways. 3 6s means 18 runs already came. Now to score the remaining 7 runs, he will have 2 options. 6s are over. Now with boundaries. 1 boundary he can hit or 0 boundaries he can hit. Okay. Remaining can be managed using singles. Therefore, in 2 different ways we can do that. Moving on to the 3rd case, case number 3. Here is case number 3. What if he hits 2 6s? 2 6s means 12 runs are over. Out of 25, 12 runs already came. Balance 13. Balance 13. He can hit one boundary. He can hit two boundaries. He can hit three boundaries. He is not hitting any boundaries. Remaining singles, that is there. Okay. Once sixes are over, then you will have to check boundaries. Okay. He can manage with 0 boundaries after hitting 2 sixes. He can manage with 1 boundary. Remaining singles, that is there. Or he can manage with 2 boundaries or 3 boundaries. So 1, 2, 3, 4. Now let us go to case number 2. He has hit only 1 6. Out of 25, 1 6. Meaning remaining 19. How can he score? Remaining 19. Remaining 19. Okay. 0 boundary. Yeah, 0 boundary. All 19 singles only. 1 boundary. 2 boundaries. 3 boundaries. 4 boundaries. 5 boundaries, no. Because 5 was a 20. We want only 19. So these are the 5 different cases. Now moving on to last one. The first case, no sixes. He has not hit even 1 6. Meaning all the 25 runs are managed by only boundaries and singles. So coming to boundaries, he can hit 0 boundary. He can hit 1 boundary, remaining singles. He can hit 2 boundaries, 3 boundaries, 4 boundaries, 5 boundaries, 6 boundaries he can hit, because 6 4s are 24. So 1, 2, 3, 4, 5, 6 plus 1, 7. Now you will have to just add all these to get the final answer. 7 plus 5, 7, 9, 10, 14 plus 5, 19 is the final answer. So it is very much there in the second option, and that should be marked. And similar type, I think 2018 or 19, he has asked one question. The bill was to be paid. The bill was reading 107 in a restaurant, and it should be paid using currency notes of 50 and 10 and 1. He has sufficient number of 50 rupee currency notes. He has sufficient number of 10 rupee currency notes. He has sufficient number of 1 rupee coins. Okay. In how many different ways he can pay a bill of 107 rupees. And this problem is 100% same type, on the same lines. Okay. There also you will have to do with the same thing. What if he is not using 150 rupee currency note? What if he is using only 150 rupee currency note? What if he is using 250 rupee currency notes? There you will come across 3 cases. Remaining you must manage with 10 and. So here 6s can be compared with 50 rupee currency notes there. Here boundaries can be compared with 10 rupee currency notes there. Here 1 rupee coins can be compared with 1 rupee coins there. And here it is 25 runs, so there it is 107 rupees bill. Okay. So according to me they are 200% same type. This is everything about this problem. Moving on to the next one. A digit number ABC on multiplication with D gives 37DD. 936 if you take, divide by into 4. A 3-digit number ABC on multiplication with D gives 37DD, where ABC and D are different non-zero digits. What is the value of A plus B plus C? Your options are 18, 16, 15. Now if you multiply this ABC and D, 4 6 are 24, 2 4 3 are 12 plus 2 14, 4 9 are 36 plus 1 37. So 3744, 37 DD means 44. Here is also D, here is also DD. Everything is all right. So in place of A, B, C, we have got 9, 3, 6. Just add all these to get the final answer. 18 is the final answer. So the very first option should be marked. Now your doubt may be how I assume this 936. That can be the only possible doubt here. And one more important thing, while creating this problem, he must have used these numbers. This is how this problem was originally created. Okay, that is one thing. Now, how I manage this 936? Okay, now let us check out that. The final answer is 18. That is the end of this. Now, how I managed? You take any number here, A, B, C, into, okay. If I write here 4, we must get here also 4, 4, right? If you write 3 here, you must get 3, 3. So what I did was 3, 7, DD divide by D. This is what I have done. Okay. If you divide this by D, you must get different digits here. Okay. So try out some digits there. If you take 3755, divide by 5, because the same thing you must take. Okay. So 5 7s are 35, 2 25, 5 5s are 25. Again, the same 5 is coming here. That is why 5 is ruled out from this place. Then I took 6, then I took, I think 4, and I got the final number. Okay. So 3 7. If you take 4 4, here also 4, then 4 9s are 36, 4 3s are 12, 4 6s are 24, right? Here what you will have to observe is these digits should be different. Okay, this is A, this is B, this is C, this is D, and D is repeated here also. Okay, this is how you will have to guess, and it didn't take much time, to me at least. Okay, so what you must do, first you check 5. It is better you always go with 5, then go with 6 and 4, and you will get it. Okay, this is how I have come to that number 936. Okay, this is everything about this problem. Moving on to the next one, ABCD is square. 1 point on each of AB and CD and 2 distinct points on each of BC and DA are chosen. How many distinct triangles can be drawn using any 3 points as vertices out of these 6 points? See here, N is 6 here, total number of points. And to draw a triangle, you require 3 points. It is a case of combinations. 6C3, start with 6, write down 3 numbers. 6, 5, 4. Start with 3, go till 1, 3, 2, 1. 3 to the 6, 6. The final answer is 20. So final answer is 20. So we are least bothered about whether it is square or all, but still let's see how it works. ABCD is a square, and what he is saying, 1 point on each of AB and CD. AB and CD 1 point. 2 distinct points on each of BC and DA. BC and DA. BC and DA are chosen. How many distinct triangles that can be drawn? These are the 6 points you have got. 1, 2, 3, 4, 5. Any 6. Okay, how many distinct triangles that can be drawn using any 3 points as vertices out of these 6 points? Right? BC and D. Okay. So we have been given 6 points, and to draw a triangle we require 3 points. And how many triangles you can draw? It is 6C3. Start with 6, otherwise you can go with the formula. This is the formula which you can take down. So if you use formula, what happens? 6C3, 6, 3, 6 minus 3. 6 factorial, 6, 5, 4, 3, 2, 1. 3 factorial, 3, 2, 1. 6 minus 3 is 3 factorial. 3 factorial is again 3 to 1. 3 to 1, 3 to 1 will go. 3 to the 6, 6 will go. 5 into 4. Again the answer is third option, 20. Right? What is the sum of all the digits which appear in all the integers from 10 to 100? Your options are 855, 856, 910, 911. Right? What is the sum of all the digits? So the journey is from 10 to 100, right? 10 to 100. From 10 to 100, we will come across only one 3-digit number. Only one 3-digit number, that is 100. So let us remove that 100. Let us concentrate only on 10 to 99 first, because all are 2-digit numbers. All are 2-digit numbers. It is the smallest 2-digit number. This is the greatest 2-digit number. Right? So 10 to 99. Let us start the journey. 1. Let us concentrate only on 1 first. 1. Where all it will appear? First, it appears here 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Here 10 times. Here 1 time, 11 times. In the 10th place, how many times it is appearing? Here 9 times, here 1 time, 10 times it is appearing. Right? 10 times it is appearing. Coming to unit place, 11, 21, 31, 41, 51, 61, 71, 81, 91. Right? Unit place, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10th place 10 times, unit place 9 times. And how about 2? 2 also the same thing. 10th place 10 times, unit place 9 times. 1, 2, 3, these many 9 times. And 20, 21, 22, 23, meaning each and every digit will appear 19 times. This is a point to be noted. Okay. So 1, coming to 1, it is appearing 19 times. Coming to 2, it is appearing 19 times. Coming to 3, it is appearing 19 times. And this is how it goes till 9. And you will have to add all these. And don't forget to add in the end 1 also, because in 3-digit number 100, you will get to see only 1. That should also be counted. That will come in the end. But for now it is like this. 19 is common. 1, 2, 3, 4 up to 9. 19 is 1 is appearing 19 times, 2 is appearing 19 times, 3 is appearing 19 times. Like this it goes. Okay. I will give one more example with 8. 8, when you write 80 first time, 10th place. 81, 82 up to 89. Here 9 times, here 1 time. 10 times. 10 times it has appeared. This is about 10th place. Coming to unit place, 18, 28, 38. This is how it goes till 98. Here 9 times. So 10 times plus 9 times 8, 19 times. So each and every digit, you take any digit randomly and it is appearing how many times? 19 times. So 19 times 1, 19 times 2, 19 times 3, it goes like this. And in the end, as I told you, it is 100. 100 is 1 only, because 1 plus 0 plus 0. We want the sum, right, of all the digits. Now 19 as it is, 1 to 9, there is a formula, n plus 1 by 2 to add natural numbers. So it will be 9 plus 1 by 2. In the end it is plus 1. 2 ones are 2 5s are. 2 ones are 2 5s are. 5 9s are 45 plus 1. 19 5s are 9. 19 4s are plus 1. The final answer is it there in the options? The second option is correct answer. So don't count randomly. And that is one more important thing. I gave you too many examples. That is the reason it is looking, too many calculations. I am not doing too many calculations. You can directly come to this step, solve this to get the final answer. Okay. Each and every digit is appearing 19 times. That is the key point here to be noted. And forget this and make it 99. 10 to 99. After that, 1 you can add. Okay. In the end. So the final answer is second option, 856. Moving on to the next one. Let x be a positive integer such that 7x plus 96 is divisible by x. How many values of x are possible? Your options are 10, 11, 12 and infinitely many. Okay. There are too many. Last option. Okay. So how to solve this problem? Check 96, the factors of 96. 1 can divide 96. Of course. 2 can divide 96. Yeah. 3 can divide 96. 4. Yes. 5. No. 6. 6 16s. 7. No. 8. Yes. 9. No. 10. No. 11. No. 12. 12 8 are 96. Yes. 12. Then 13, 14, 15, 16, 6 are 96. So you will have to enlist these numbers. Which are the numbers that can divide 96? Forget about 7x and all. Concentrate only on 96 first. Okay. 17, 18, 19, 20, 21, 22, 20. And one more important thing. After initial phase, it will be only multiples of 4 here. See here. 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20. Check it out. 20 will not divide. Okay. 4 6 are 24. 24 will divide 96. right? So 24 is there, then what else? 24, 28, no. 32, yes. 36, no. 40, 44, 48, and after this straight away it is 96. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that is the final answer. Now I will tell you what to do with these numbers and how this became the final answer. Okay. Now let us check at least some of these. Okay. We will check one in the beginning, one in the middle, and one in the end. Okay. So first let me check this 3. Possible how many values of x? 3 is a value of x. Now I will tell you how. 3 is a value of x. In place of x, let me write 3. 21 plus 96. 6 plus 1, 7. 2 plus 9, 11. Since I have taken x value 3, it can divide. 3 can divide this. 3 3s are 9. 3 9s are 27. Of course, that x value will divide, can divide. You take any values here and it will divide the sum of 7x and 96. We will take a different example. One more example, 12. If you take 12, 7 into 12 plus 96. And now I am checking whether 12 can divide this total. 12 7s are 84. 96. 12 of course can divide this. 12 ones are 12. 12 5s are 60. And one more important thing. When I wrote 7 into 12 plus this 96 is of course divisible by 12, that we already learned here. That is the reason why we have enlisted all this. So this will be 12 into 8. 12 is common in both. Take it out. 7 plus 8. Meaning 12 into 15. Meaning 12 can divide that number. Okay. It only goes to say that here you will have to concentrate only on 96. Forget the rest. So which are the numbers that can divide this number 96? Enlist all the numbers and that is the end of it. Okay. So afterwards you can check 48, 96 and all. Okay. So these are the only numbers which will suit, which will fit in the shoes of x. Okay. This is everything about this problem. Moving on to the next one, problem number 17. A number n is formed by writing 9 for 99 times. What is the remainder if n is divided by 13? So it is again a problem on divisibility of number by 13. How to check whether the given number is divisible by 13 or not? If I write it like this, 1 2 6 1, is it divisible by 13? How to check? Start from the right hand side and keep on making a group of 3 digits. 1 2 3. So one part is 1, the other part is 261. If you check the difference, it is 260. 260 is of course divisible by 13. 13 2s are 26. Since the difference is divisible by 13, this is also divisible by 13. Okay. So how to check whether the given number is divisible by 13 or not? Start from the right hand side. Keep on making a group of 3 digits. Okay. That is one thing. Now, what if we come across too many groups? Assume it is like this: 5 4 6 7 8 3 9 1. Okay. If it is like this, Take these two groups separately, add them. Take these two separately, add them, check the difference. Okay. And one more important thing. 13 zeros are 0. Meaning 0 is divisible by 13. This is one more important, crucial point. 13 can divide 0 as well. Okay. Now we are in a better position to solve this problem. So we are writing 9, how many times? 99 times. Like this. How many times? 99 times you are writing. Group, if you start making the groups, then you will get to see 33 groups, because 33 threes are 99. 33 groups you can do. You can go with 33 groups. So if there are 32 groups, then it is completely divisible by 13. Assuming there are 32 groups only, meaning 96 times. Assuming they are 999, 96 times, then you will get to see 32 groups. 32 groups, 99999. Okay. Group of 9, 32 groups, then the remainder will become 0, because 13 can divide the number completely. But in the end, you will be left out with one group. In the end, you will be left out with one group, and you will have to divide only that by 13, because the rest of the things will get completely divided by 13, because 32 groups means 16 groups, and remaining 16 groups, they will get squared off. So one group will remain 999. 13 sevens are 91. This is it. 13 6 are 78. The final answer is the very first option, 11. Okay. So if there are even number of groups of 3, then remainder will be 0 when you divide that number by 7, 11, 13, 1001, 1001. Okay. But here one group is left out, and you will have to check only that group. Okay. So this is everything about this. So thank you one and all for watching this video, and I'll be coming out with at least one more video on the same question paper 2023 CSAT. Take care. Till then, bye bye. Thank you.